Hello everyone. In this video, we're going to continue with Lesson 8 and talk about the concrete steps of a hypothesis test. What do I expect you to do? How do I test those claims that I talked about a lot in the first video? So, a hypothesis, in general, is a statement about a population. And it's usually claiming that a parameter takes on a particular numerical value or falls in a range of values. All right? So, there are two types of hypotheses that we'll talk about here. The first is the null hypothesis. It's a statement about the parameter. It's a statement that the parameter takes on a specific value. It's typically the claim that you want to prove is untrue. So in our example, in our example about the coin, it would be that the coin is fair, which translates to the proportion of heads equals 0.5. Okay? And then there's an alternative hypothesis. It's the opposing statement to the null hypothesis that states the parameter falls in a range of possible values. What does that mean? It means that there's going to be an inequality there. So the alternative hypothesis for that first example, unfair, is that you can be unfair in two directions. It could be really low, the probability of success could be really low, or it could be really high. And so my alternative hypothesis in sort of math or statistical terms would be that p is not 0.5, which translates to p is not equal to 0.5. It turns out that in this class we'll talk about three different types of alternative hypotheses. One that has a less than sign in it, one that has a greater than sign, and one that has a not equal to sign. Okay, so an example of hypotheses that we'll see is this. The null hypothesis is that p equals 0.25. Okay, so that's from just any example. That's not our coin example. That's just some random number. Okay, so our null hypothesis is that p, the probability of success of whatever, is equal to a quarter or 0.25. Okay, and our alternative hypothesis is that p is less than 0.25. Okay, that also came out of nowhere. Is just an example. But what you should notice about the null and alternative hypotheses here is that the letter on the left side of the hypotheses, okay, which is p, it's going to be the same on both hypotheses. Okay, so the null hypothesis should have a p on the left side, and so should the alternative. And you'll also notice that on the right side, those numbers should be equal as well. Okay, 0.25 and 0.25. That has to be true for a valid hypothesis. Okay, so the null hypothesis is a statement of agreement. I usually like to call it. Okay, a statement of agreement. It's always equaling something. Okay, and the alternative hypothesis is always going to be some sort of inequality. It could be less than, greater than, or not equal to. So here is the first your turn. Okay, and what you're going to do in this your turn is just state the correct null and alternative hypotheses that I would see if I was trying to test the claim. So the claim is I'm interested in seeing if a majority of the US population believes that Marvel superheroes are superior to DC superheroes. So if you like comic books, and if you like comics or superhero movies or whatever, okay, you'll know that two of the large companies are Marvel and DC. Okay, and so there are lots of debates that I don't know nearly enough about to talk intelligently about them, but I'm giving you just a toy example here. Okay, so I want to see if a majority of the US population believes that Marvel superheroes are superior to DC. So I want you to state the null and alternative hypotheses here. Okay, so as a hint, the question gives you the alternative hypothesis. Okay, but you know about the structure of the hypotheses that you need to make. Okay, and that'll give you a hint about the null hypothesis. So the question gives you the alternative, and then with that information, you can then build the null hypothesis. All right, so we'll talk more about here the steps of a hypothesis test. So the first step was the hypotheses. So you first have to state the hypotheses. The second step talks about a significance level. And so you may say, well, we've never mentioned that word before. And that's true. So let me talk about that here. So level of significance. It's a small but important step in the hypothesis test. Okay. The level of significance, specifically, you don't need to worry about this too much, but it's interpreted as the probability of rejecting the null hypothesis when I should have failed to reject the null hypothesis. Okay? So that's equivalent to sending an innocent man to jail. Right? If we thought about the hypothesis testing steps in a real court of law environment, the null hypothesis is that he's innocent. The alternative is that he's guilty. The level of significance, which is something that we're going to set before we do a hypothesis test, okay, is the probability of rejecting that null hypothesis, which would be innocence, when in fact the person was really innocent. Okay, so that's equivalent to sending an innocent man to jail, which is not good at all. So it is the ultimate failure of the justice system, is to send an innocent person to jail. So this is a bad thing, and it's actually something that we can control for in our hypothesis test. All right, so this is a type of error in hypothesis testing, or it's often called significance testing, called a type 1 error. Again, these are important to know, but not really crucial to actually doing a hypothesis test. So if this goes over your head, I want you to sit down and take time to think about it, but don't dwell on it too long. In reality, this is chosen before the sample is taken. Okay? So when I actually go out and take a sample, I already have this number in mind. It doesn't really affect how my sample is taken, but it's important that you set this before you see your data or do the hypothesis test. We're going to use the level of significance to make our decision about whether we support the alternative hypothesis or the null hypothesis. In our examples, the value will usually be given in the problem. So I'm going to tell you what it is. So in the grand scheme of things, you're not going to spend very much time thinking about the level of significance when you do the problems, but it is an important step. If I don't tell you what the level of significance is, you're going to assume that it's 0.05, okay? Or there would be a 5% chance of sending an innocent person to jail. All right, so as a reading assignment to get these ideas down in probably a more eloquent way than I'm doing at the moment, you can read pages 387 to 391 in our textbook. Now, those were some big ideas before we get to the actual steps. Now we're going to get to the steps that I want you to complete in doing a hypothesis test. The first step, besides the actually stating the hypotheses, is to identify what parameters that we're actually interested in testing. Okay? And so this is important because later on we're going to learn about hypothesis tests for other things than P. And so it's important to think about the problem and think about what parameter that you're actually interested in. Again, a parameter is a value about the population. Okay, so for a coin, it's like true probability of being heads. okay, for all flips ever. So an example would be, in my example that I used in lesson 6 and I believe in lesson 7 as well, P would be the parameter that I'm looking for, and I would define P as the proportion of winning bottles in all Coke bottles during the challenge that I had, okay, that I talked about before. The second step, after identifying what parameters that you're actually interested in the problem, is to identify the null and alternative hypotheses. Okay, so you're going to write those down, and it looks like this. For the null hypothesis, I usually write H with a subscript of 0, and you're not going to read that as HO or HO or something like that. You should read it as H naught. H naught. So you could use the sort of English, maybe English NAUGHT or naught, or you could just say H NOT, H naught. Okay, and then in the second one, the alternative hypothesis, I usually denote that with an H with a subscript of A. Okay, often said HA or alternative hypothesis. Okay, and so if you take away how you say them, H naught and HA, okay, that is exactly how I want you to state the null and alternative hypotheses. Okay, just like that. Okay. Step 3 is to choose that level of significance that I talked about in the last slide. Okay. And so it's going to tell you in the problem what that level of significance should be. Right. Again, we don't really know why that's important yet, other than the reasons that I gave before. Okay, but it serves directly in later steps. The fourth step of a hypothesis test are assumptions. Okay, are assumptions. So we haven't really talked about making decisions or really how to do a hypothesis test yet. We're beginning to right now. Right. When we do, we're going to use the sampling distribution of the statistic that we take and collect. And so, because we're using a sampling distribution, there are assumptions that go with that, and they're going to translate to the assumptions here. Okay, so the assumptions are going to be the same or at least similar to assumptions for a confidence interval or sampling distribution that we already did. All right. The next step is to find the test statistic. This test statistic is going to give us some sense of how far away my sample is from what the expected outcome is under the null hypothesis. So we're going to assume that null hypothesis is true. Null hypothesis is true. And then this test statistic is going to tell us how far from that original hypothesis our sample is. Okay? Every test statistic calculates the distance between our sample and the hypothesized value. Okay? And so all the test statistic is going to be a z-score. Okay? So I don't know a better way to say that. Every test statistic that we use is just going to be a z-score. All right? And the z-score looks like this. Okay? On the left side of my fraction here, I have the point estimate. Okay? So I take a sample, and then maybe I'm calculating the sample proportion. So I calculate that sample proportion. That's my point estimate, minus the hypothesized value. This is the value in the null hypothesis. Okay? And then I divide by the standard error of the point estimate. Again, that stuff comes from lesson 6. Okay? So I calculate that z-score, and then in step 6, which is maybe the most important step of a hypothesis test, is to calculate what's called a p-value. Okay? A p-value has a long and notorious history in statistics. Some people love it, but most people actually hate it. But that's for another class and another time. Okay, the p-value is the probability that I observed your sample, or something less likely, given that the null hypothesis is true. Okay, it's the probability that I observed what I saw, or something more weird, given that the null hypothesis is true. Okay, so p-values are often misrepresentative and misrepresented and misunderstood. People like to think that it says something more than that, but it doesn't. So if you go on to use statistics in your field of study, you'll most likely encounter p-values and hypothesis tests. And so you should print this out and remember it. Okay? You may not understand what the heck's going on now, but then you probably will. All right? Anyway, so after we find the p-value, it's a probability. It's the probability that I actually saw what I saw, or something weirder, given the null hypothesis is true. We make a decision. Okay? Based on that p-value, we make a decision whether we favor the null hypothesis or the alternative hypothesis. So, once we find the p-value, you compare it to the significance level, which is actually step 3. It shouldn't say step 2. Okay? Step 3, you compare it to the significance level. If the p-value is less than that significance level, then you reject the null hypothesis. If it's greater than or equal to the significance level, then you fail to reject the null hypothesis. All right? And so if there's one thing operationally that you remember from this about hypothesis test, it's this line. If p is less than alpha, you reject. If p is greater than or equal to alpha, you fail to reject the null hypothesis. Okay? So that's the decision. Okay? The decision is rejecting or failing to reject the null hypothesis. The conclusion is restating the decision in terms of the problem. Okay? So what does it mean that I reject the null hypothesis or fail to reject the null hypothesis? What does that mean? Okay? And so that's what you're going to say. For example, this is how I would write a conclusion about that Koch problem that we were talking about before. Since the p-value is greater than alpha, okay, so suppose the p-value was actually greater than 0.05, okay, I would say there's not enough evidence to conclude that the proportion of Coke bottles with winners is less than 25%. Okay? That's how you would state a conclusion. Okay, so next time in the last video, we'll go through the specific tests the specific steps for an actual hypothesis test for proportions. Okay, the last slide applies to all hypothesis tests. This one is going to be for proportions.